Hello, and welcome to our lesson on adding and subtracting rational expressions. So, for this lesson of adding and subtracting, you need to make sure, just like with most, or I shouldn't say most, with all fractions, you need to have a common denominator before you're able to add or subtract. So for this lesson, we're also following up on that concept, but in this case, we are calling it a least common multiple, which will become the common denominator when we're dealing with expressions that are rational. So what I mean by that, find the least common multiple for each pair of expressions. So a least common multiple is the approach we use to figure out our common denominator. And the least common multiple, or LCM, is the smallest product that has both values as possible factors. So what that means, if we're looking at A, we have 3x and 9x to the third. So if we're looking at just the 3 and 9, the coefficients out in front, multiples of 3 are 3, 6, 9, 12, 15, and so on. Multiples of 9 are 9, 18, 27, 36, and so on. Then we take the variable pieces of x and x to the third, and the smallest multiple that they share, we'd make the list again of their different multiples. So x to the first as times 1 would give us x to the first. Then we'd have x squared, x to the third, x to the fourth, and so on. And x to the third, the first one is x to the third. So when we're looking at least common multiple, it is the smallest product where both values we were given, 3x and 9x cubed, are possible factors. So in this case, 9, the smallest multiple out in front, and x cubed is our LCM. So for 3x and 9x cubed, the least common multiple is 9x cubed. In B, we have 10 and 4x squared. So we're thinking, again, what is the least common multiple that both 10 and 4x squared are factors of? So the smallest number that both 10 and 4 are factors of would be 20. Because if we're listing the multiples of 10, we have 10, 20, 30, 40, and so on. Multiples of 4, 4, 8, 12, 16, 20. And then, because the 10 doesn't have any variable, we just take the variable piece from the other factor, being x squared, and attach that to our answer. So 20x squared is our least common multiple. We get that by taking the 10, multiplying it by 2x squared, and taking the 4x squared times 5. So both of our original values, 4x squared and 10, are factors of this product. And then in C, the least common multiple of 8x and 6x. So x is shared by both, so I know x will be part of my answer. And the smallest number that both 6 and 8 multiply into is 24. So if I'd take my 8x times 3 and my 6x times 4, I get 24x. So 24x is my least common multiple. Now, as I mentioned, the reason that we need a least common multiple is if we're adding or subtracting, we need a common denominator first. The way that we get that common denominator is using the least common multiple of the denominators, which creates the least common denominator. Once we have that common denominator, we can add or subtract the numerators, just like we do with any fraction, and then we can simplify. So in A, 7 over 2x plus 2x minus 7 over 2x. They already have a common denominator, so I'm just going to add the numerators on top. 7 plus 2x minus 7, a positive 7 and a negative 7 cancel. So I have 2x over 2x, which simplifies to 1. In B, we have 3 over 4x minus 1 over 6x squared. So in this case, I need to figure out my least common multiple of the denominators to get my LCD. So the smallest number that both 4 and 6 go into is 12. And then the smallest value that x and x squared both multiply into is x squared. So our common denominator is 12x squared. So just like with normal fractions, how do we get there? So to get the 4x to 12x squared, I need to multiply the fraction on the left by 3x. To get the 6x squared to 12x squared, I need to multiply that fraction by 2. So whatever you do to the bottom, you must do to the top in this case with multiplication. So 3x times both top and bottom gives me 9x over 12x squared. Then on the right, we have 2 times the top and bottom gives me 2 over 12x squared. Now, 9x minus 2 on top, the 12x squared on bottom. We want to check, can we simplify anything there? No, we cannot. So our final answer is 9x minus 2 over 12x squared. Now let's look at C and D. So again, in C, we have a subtraction problem. Doesn't change the steps, just have to make sure we subtract instead of add. So 5x and x to the third, I need to figure out my least common denominator, which would be 5x to the third. So then I need to convert both fractions to the common denominator. So the fraction on the left, to get 5x to 5x to the third, I need to multiply that fraction by x squared. The fraction on the right, to get x to the third to 5x to the third, that fraction needs to be multiplied by 5. Do our multiplication, and we have 9x squared over 5x to the third minus, and on this one you need the distributive property, 5x squared minus 10 over 5x to the third. Now we can subtract on top. 9x squared minus 5x squared gives me a negative 4x squared minus 10. And then on bottom is still 5x to the third. Check to see if we can simplify, which we cannot. So that is our final answer. And then D. So in D, we have the 6x on bottom and a 13x on bottom. So in this case, 6 times 13 gives me the smallest multiple of 78. Both share an x, so my least common denominator is 78x. So then on the left, multiply that fraction by 13, and the one on the right gets multiplied by 6 to get our denominators to 78x. So then we end up with 143 minus 39x over 78x plus 12 plus 24x over 78x. Combine our numerators, and we end up with 155 minus 15x over 78x. Now ignore that note here with the page number. Don't need that. That was for a regular school year piece. And we're going to look at this part here. So now, what if we're dealing with binomials rather than just monomials? How do we figure out the least common multiple for each pair of those? So if we have 2x to the fourth and x plus 2, again, we want to think of the smallest multiple both go into. Well, if I simply look at x plus 2, and if I double both of those, I'd get 2x plus 4. So my least common multiple is 2x plus 4, because 1 times 2x plus 4 is still 2x plus 4, and 2 times x plus 2, distributive property, gives us 2x plus 4. In B, what I'd advise doing in B is if we have x squared minus 9 as one of our pieces and x minus 3 as the other. X squared minus 9 is the same thing as x plus 3, x minus 3. So in that case, that gives us a big hint toward the common multiple. Well, our other expression is x minus 3. So if I'd multiply that by x plus 3, I get x squared minus 9. So x squared minus 9 is my least common multiple, because on the left, multiply by 1, and on the right, the x minus 3, we'd multiply by x plus 3. And then in C, if you're not sure what you could do to come up with a common multiple, so if both expressions are like x plus 1 and 2x plus 3, well, if I double the x plus 1, I get 2x plus 2. That doesn't get me anything good. I need them to match, and I can't think of a good number I can multiply both by. Well, then, the easiest solution is to multiply the two binomials together. So x plus 1 times 2x plus 3. Then we're going to FOIL these. So first outer, inner, last. 2x squared plus 3x plus 2x plus 3. Combine like terms. And our common multiple is 2x squared plus 5x plus 3. So when you're in doubt, easy way to come up with a common denominator, if you have two different binomials on bottom, is to just multiply them by each other. So looking now at a few of these examples, in A, they already have the common denominator, so we just have to combine the numerators. 2m plus 5 over 3m minus 4. Check to simplify, which we cannot do, so we'll move on to B. In B, when we look at that, numerators are already the same, so that's good. Now you want to make sure you're doing the correct operation, which is subtraction. And sorry, I meant denominators are the same. So in this case, we can just subtract on top. 3x minus x is 2x, and then the minus a positive 1 would give me a negative 1 here on top. So plus a negative 1, or minus 1. So then I have 2x minus 1 on top, and the bottom is 2x squared plus 3x minus 2. Now, because the bottom's a trinomial, when I check to simplify, I want to factor that. So my trinomial on bottom factors to 2x minus 1 times x plus 2. The 2x minus 1 cancels on top and bottom, and we have 1 over x plus 2. And then C and D. In C and D, x minus 2 can easily become 5x minus 10 if we just multiply each part by 5. So our common denominator is 5x minus 10. So in this case, multiply the left by 5, and we get 10x over 5x minus 10 plus x plus 9 over 5x minus 10. Combine like terms on top, and we have 11x plus 9 over 5x minus 10. In D, our denominators are x plus 1 and x. So if you can't think of an easy way to come up with a common multiple, you just multiply the two fractions by the other one's denominator. So on the left, we're multiplying by x, and on the right, we're multiplying by x plus 1. So we do our multiplication, and we end up with 2x to the third over x squared plus x minus, and then do our foiling on top. Difference of two squares gives us x squared minus 1. Multiply on bottom, x squared plus x. Now, subtract in between. So when we combine, we have 2x to the third minus x squared plus 1. So this answer would be perfectly acceptable, or you could on bottom technically factor out the x and write it as x times x plus 1. So either answer here would be good. We cannot simplify anything between the numerator and denominator. Then our last two examples. In E and F, so in E, we have x minus 1 on bottom and x plus 6. So I'm just going to multiply them by each other to get my common denominator. So when I do that, my fraction on the left, both top and bottom get multiplied by x plus 6. Fraction on the right, both top and bottom get multiplied by x minus 1. So now we are going to FOIL on the left, distribute and FOIL on the right, and we end up with x squared plus 8x plus 12 over, and you'll notice I did not do anything with the denominators yet. I left them already factored. So then in the end, when I look to simplify, it makes that process easier. Now on the right, 12 times x minus 1 gives me 12x minus 12. Subtraction in the middle, so combine like terms, x squared. A positive 8x minus 12x is a negative 4x, and the positive 12 minus a negative 12 gives us a plus 12, so 12 plus 12 is a positive 24. So then in this case, I have x squared, x squared minus 4x plus 24 over x plus 6, x minus 6. Now, what we want to think about in this case is if we could factor the top to anything that would be divisible by the bottom. Now, in this case, a positive 24 and a minus 4x, if I'm thinking about like 6 times 4 is 24, the difference doesn't work to give me negative 4. 8 times 3, still not a difference of negative 4. So I cannot cleanly factor the top. So this is my final answer. And then in F, we have 6x minus 1 times 81 minus x squared minus 2x over x plus 9. Now on the left, I never like it where it's the number minus the variable, especially when the other fraction's set up with the variable first. So if I multiply by negative 1, that just flips the order and the values on top and bottom. So negative 1 multiplied by the top and bottom on the left becomes 1 minus 6x over x squared minus 81. Now, my common denominator is easier to get because x plus 9 times x minus 9 gives me x squared minus 81. So for a common denominator, I need to multiply the right by x minus 9. So then we end up with 1 minus 6x over x squared minus 81 minus 2x squared minus 18x over x squared minus 81. Do our subtraction on top, and we have a negative 2x squared plus 12x plus 1 over x squared minus 81, which is a perfectly good final answer. Or if you wanted to go a step further and factor the bottom to x plus 9, x minus 9, that would also be fine.